A very good afternoon to everybody that is joining us this afternoon. My name is Willie, and thank you for attending this webinar. It's really much appreciated. So let us jump in. As Bradley has put and Johan on the side, if you have any questions, please put it on the side note here for us. I'll keep an eye on it, and some of the team here will help me to answer those questions when needed on it. Right. The triple threat of COVID-19, climate change, and wind and solar integration will fundamentally change how grids operate and how, in turn, they need to be managed. What we are seeing is a simultaneous shift from a thermal, dispatchable, consolidated, and a predicted grid to a renewable, non-dispatchable, distributed, and unpredictable grid. Now, in the coming decades, we will most likely see a greater fundamental shift than we've ever seen since the inception of the power grid. A lot of changes is coming our way. Our industry is very conservative and is highly optimized for the dispatchable power. The energy space was also dominated for too long by too few big players. Now, the big boys just slowed down change and they killed innovation. And this space now is absolutely ripe for disruption right now. And industry's focus today is on the zone substation as the key building block to build a smarter grid. If I can just quickly relate to the UK, for instance, their grid code is putting restrictions on every single device connected to the grid, zone substations, generation, IPP, everybody. And in that grid code, they determine rate of change of load, no oscillations, the damping of changing load and so on, and in a way to protect the stability of the grid. So the zone substation, the substation connected to the transmission grid is really becoming the cornerstone of a strategy for the future. The dynamic behavior of the grid is constantly push closer to instability. Today, most networks have to respond within 5 to 7 cycles to prevent instability. So you can imagine we are not talking about 10-minute, 15-minute kind of thing. It is down to cycles that the system have to be operated in. The challenge in the past was to guarantee that the generation mix respond fast enough to sudden load changes. And the new challenge is that dynamic behavior of the zone substation be adequately controlled to respond to sudden changes in embedded and external generation. In other words, the substation will just become more and more important and intelligent. Autonomous control at the zone substation will become essential. Now, many systems within a grid operate as islands. Very little communication links between network components, and in some places it's completely non-existing. In other words, things are really operated in island modes. Most databases or data sets used to operate and control the network components are incomplete. So it doesn't contain the correct parameters that sits in there. And then most of them is also not correctly time-stamped. So that makes it very difficult to analyze data afterwards. So a lot of human intervention and all of that murk the water that you want to play with. Now, the little data that is gathered is classic, traditionally also locked up in a control room, and only a select few have access to it. But in other words, there's no drive to systematically digitize the grid and share that information throughout the organization, and let alone to share some of that information outside the organization. Now, real-time visibility of the grid just isn't available within Australia today. Without accurate grid-wide data, change is just guesswork. Now, CT Lab was founded in 1993, and we've been involved with power quality since inception. Now, throughout the years, we've learned a lot of lessons, and in 2013, roughly around that time, we started to reinvent ourselves and not to just be compliant to the South African market, but to really address the international opportunities that sits there. And so then we started the first building block of the system that's today called OTELLO. Now, OTELLO had 4 design pillars that we used as design criteria for it. Firstly, it needed to be scalable. And scalable means not just to have thousands of devices connected simultaneously to the system, but also to run one device. But that is, you got to scale from 1 to thousands of devices in the other side. I think that was a tremendous challenge that we successfully mitigated in our technology. The second criteria was to be comprehensive. You know, the device, when you make all the effort to get it installed in a place, you have to have a comprehensive data set. You can switch off and switch on as you need, but as today data might not be important, but tomorrow that unimportant parameter might become a cornerstone of some other strategy that might interest you on that side. So it needs to be comprehensive. The third leg was to be resilient, and resilience is different than reliability. Resilience is when that system goes down or a part of the system goes down. You got to be able to really recover within a very short period of time. Now, we've built in a lot of tools on our devices for that. For instance, we have the concept of a measurement campaign. So there's a central set of rules that you can define that will automatically be inherited by any device that's out in the field. So if I can take a practical case study, if a device is struck by lightning and it fails, the operator just have to go and replace the device. In the moment when you start up the second device, it will automatically inherit all the data or all the settings that was prevalent to the previous device that was installed there on that side. And then finally, it had to be user-friendly. Now, we live in Africa, and in Africa, there's a big problem or a big shortage of skilled knowledge. And so if you don't make things friendly and you convert raw data into information that can be used to make data-driven decisions, you're dead. So that was an absolute must for the challenge here. The advantage of that is that there is so much done on the device that the final user don't have to do, that it's a tremendous time saving, and it helps you to instantaneously visualize and interpret what's happening on the grid on that side. Now, OTELLO is comprised of 2 parts. On the left-hand side, we have Osprey Pro, and Osprey Pro is a big data hosting, analysis, visualization, and a grid management platform. And on the right-hand side, you have the Vector 3, the digitizing device, or the field recording device. The Vector 3 is GPS synchronized. It's an edge computing device. It runs Linux on board, and all the cybersecurity and things is there. And they are permanently connected to each other, but also the devices to each other through the network. So their end result is to have a permanently connected, time synchronized processing power at every single node in the grid. Yeah. So what we have is a Class A multifunction monitoring device that's a lot more than a power quality analyzer or a smart meter, as the term is currently understood. So it's really quite a multifunction, and it does have the ability to grow with you in the field as the need change. Now, OTELLO impacts virtually every area of the grid management, and when paired with other solutions in aligned fields, there's potential to usurp the field of grid management entirely with this device. So just a comment there, the OTELLO system is open to accept data from third-party devices. So it is possible to connect it to, for instance, a smart grid measurement program, or even on the relay bays to bring in COMTRADE files from protection relays and so on. There is a lot of integration scope on this particular unit. Now, how does it work? OTELLO devices are installed wherever the grid interconnects. So where it's important, typically it's a top-down approach, and each device is permanently connected to a central cloud-based big data host via secure IP-based links. So data is encrypted, the device has got a built-in modem, and that modem is also battery backed up, and the GPS battery backed up. So even in the event of total power failure, you still have communication out in the field, and that communication is live for at least an hour after a load has been lost from that side. On the security side, the default connection is encrypted, but if you operate it over your own network and APN, everything is encrypted. But if you do opt to operate it out of a cellular network, we can automatically connect the VPN from the device to the central database, which really makes a very secure connection. Yeah. All right, each device has a built-in GPS, a cell modem, and a battery, and the device clocks are permanently synchronized within about 100 nanoseconds from absolute time. And I'm giving a little bit of the technical detail here. I heard from the Australian team that we're going to have technical people this morning on the other side. So if you're not technical, please forgive us. All right. So users can access all recorded data via an interactive web interface. So everything is accessible in real time. So as the event has happened in the field, data is automatically pushed to a central database, and from there, we will automatically generate alarms and automatically analyze the data and so on. So an alarming engine will push those alarms and reports and all other information directly to end users via a push notification or an email out there. Now, the alarming engine is quite an important part of our strategy. The idea is when you install devices for the first time, you have no idea on what the characteristic numbers are. So the first objective with a measurement campaign is traditionally to make sure that you are compliant. But compliance is not enough. You can't operate a grid on its extreme values. You've got to find the operational level of each one of the parameters. And then we deploy what we call sentinels. It's thresholds that you can specify per parameter on that side. And if any one of these thresholds are exceeded, the sentinels and the alarming engine will send you a warning, and that warning will come to you personally. So the warning is not coming to a control room that need to dispatch it further and so on. So any person that is signed up to the alarms on that side will receive it instantaneously from the field. Another function that we have there is the grouping and the annotation of simultaneously occurring events. If you have a large number of devices installed in the field, the challenge is to always have a big picture. So what we do is we group everything that happens simultaneously at the same time together into one single incident. And that incident now gives us a coat hanger or a hanger space where we can tie things like, for instance, the root cause of an event, what the effect was. For instance, on every event on our system, you can specify and say, if you're a factory, that these and these and these devices on the floor were affected by it. Maybe you can even add a revenue that was lost to it and so on. And you can add pictures. So the whole thing is like a police file or a forensic file where you can collect information about that incident. There's a ticketing system as well where you can use to notify some of your key employees about things that need to be done to conclude the analysis of that particular incident at time. The real value thereof is when you get to the end of the year, you can analyze all these root causes and things, and you can, for instance, say that 50% of all events was happening upstream. It's coming from the grid, and the other 50% was happening from within the grid. You can say that of those devices, sorry, of those failures that took place within the network, how many were operator-related, vegetation, weather-related, and all those kind of things. And all of that can drive decisions to improve power quality, reliability, and yes. Another mechanism that we have is a cross-trigger mechanism. It was lately or very recently updated to a new standard. You can define a tag for every single device that's installed in the field. And devices with similar tags, with the same tag, will be able to cross-trigger each other. So for instance, if you sit inside a substation, if any one device in a substation records an anomaly, it can cross-trigger to have a picture throughout the entire substation. And vice versa, a substation can trigger substations that's sitting around it and on that side. So this mechanism is quite powerful to give you that clear picture of what has happened in it. Just a comment there, I think we're one of the devices with the biggest pre-memory available right now. You can look back in history when an event happened minutes back in history. For instance, if you have an under-frequency event, you can see the whole development of the under-frequency event as it have by going back in time minutes before the event has been triggered. Another important one that I already touched on was measurement campaigns. Measurement campaigns is a set of rules that is predefined. For instance, in South Africa, we have power quality legislation, and the settings, the dip settings for 400 volt is different than for 11 kV, and it is different for the high voltage 132 and upwards on that side. So all of these rules is being predefined and set as a measurement campaign. So when the operator defines his measurement strategy, he can enable various campaigns. For instance, as well, while running a power quality campaign, you can run a demand management campaign and maybe a billing campaign or different kind of campaign. The idea there is there are various users of the system, and you don't want to have one campaign to intrude on another one. And so behind the scenes, we take care of all the settings to make sure that each campaign record the data as needed and the minimum set of data being recorded, no duplication take place on that side. All right. The final one that I want to talk here about is automated data analysis and report generation. Now, this is an incredible time saver. You know, if you have all this raw data, you got to calculate 7-day, 99, 95 average maximum values for every day for every single parameter in the system. So all of that happens automatically behind the scenes. Then we combine that in various different reports. The most prominent one for us is called a site assessment report. So on the site assessment report, we take power quality and we split it up into voltage regulation, unbalanced THD, flicker, individual harmonics, power consumption, all of those kind of things individually. So I have a lot of powerful stuff that we record per measurement site, but we also have reports that record on the enterprise. With other words, how was the power quality looking like in the 11 kV? How is your KPIs working? The Saifis and so on from that side. So there are numerous reports that is automatically generated. And just a side note there, these reports, you can schedule them automatically yourself ad hoc as you wish, but you can also schedule these things to take place, for instance, monthly. So on a monthly end of the month, I'm managing the municipality of Stellenbosch here where I live, the power quality on their behalf. And so at the end of the month, I receive roughly about 50 reports in my mailbox. And I just have to interpret each one of the reports and write feedback back to the municipality on that side. All right. We also support, we have full support for time of use tariffs. So the way it works is you can define various tariffs on the system, and then per installation, you have to define a contract. And in the contract, things like your notified maximum demand or anything that is related to that specific measurement point is touched in the contract. And then you can run various billing reports on various tariffs, if you so wish. So you can make a tariff analysis to say, what if we change from this tariff to that tariff and so on. Just a space, we wish to, in the near future, do a lot more in this space, and specifically to take playthrough scenarios like what will happen, what will the impact be if you do peak shaving, if you do load leveling, if you shift load from one side to the other side, if you do power factor correction and so on. So there will be a whole new reporting series of reports coming in this specific space. I just also want to say here, the platform allows us to very easily, or to easily make new kinds of reports. The raw data is in place, the collection of the data is in place, and all the engines to visualize and so on is in place. So it's an absolute formality to make new reports and to visualize data in different or various ways on that side. We also, this whole tariff engine also support combined billing. So you can have as many devices as you wish, all energy combined into one, and generate a specific report for that. On top of it, the system record a very rich supporting information data set that can be used to investigate demand management options. So as I mentioned, the data set is already there. The challenge for us now is just to make it accessible and friendly and so on. So on a side note here, please, any person that can feed us with information and with wants and needs in this specific space, we'll gladly listen to what kind of suggestions you have there for us. We also support various SCADA protocols. It's Modbus is the easy one, DMP3, 61850 protocols, and that enable the device to form part of a larger demand management strategy. So you can plug it into any other demand management system by using the protocols that's available on the device itself. Just a comment, if I go back on this one, the ability to run Linux really opens up a lot of integration possibilities. The data on board of the device is actually stored in SQL. So it's not filing systems, so you can, it's very powerful. You can make queries on the data and derive new data on board and so on. This is also where the edge computing is so powerful, because on the device itself, you have a very high level of sophistication, but you've got access to 500 kilohertz sampled waveform data coming out from the field and so on. We also have a small development space in the device here called Lua. It's something similar to Visual Basic. And one of the students at the Potch University, a PhD student, implemented a complete slipping pole protection relay in that space. So we can customize functionality, and this is where automation and those kind of things come in. Now, the OTELLO system is most valuable when you integrate it as part of your daily operations. I think people don't realize the value. If you compare it with SCADA, for instance, the SCADA that brings you a breadth and width of parameters from throughout the network and so on, but the detail is missing, and the accuracy of the detail is missing. It's not always useful to analyze it, specifically when we are investigating network stability issues in SAT. So the Telesystem really augments SCADA systems, and we fully integrate with substation automation. So we are working right now on Goose and on sample values, and to improve that integration with substation automation. And it really provides valuable real-time diagnostic information as part of your daily operations. We are very confident to say that there is no system on the market right now that comes close to what OTELLO is, and to what OTELLO can do. It's a big data hosting platform built on Cassandra. Now, Cassandra is an open source big data platform, and it is used by the likes of Netflix and Amazon. And this platform, as I mentioned before, can be customized and expanded as the need grows. So the system can grow with you. And the measurement device are running Linux, as I explained, and it offers excellent cybersecurity and edge processing capabilities. And all of that will really become essential when the zone substation is being smartened up and their grid is being smartened up in the future. Right. Now, in IEMO, this was recently published, 14 billion needed in the NEM to upgrade the challenge of the distributed grid. This is a lot of money that need. And we firmly believe that the use of our technology can assist distribution operators to save on CapEx and OpEx just by prioritizing, just by making data-driven decisions. And at the same time, we can improve voltage regulation, network reliability, stability, efficiency, power quality on that side. And we have to start with the digitization of the grid. There's a lot of talks about it. There's a lot of papers being written and so on, but practically in the field, not many people are doing it. And I think in Australia's case, you are running one of the biggest, if I can use Phil's words, experiments in renewable integration in the world. And I firmly believe that there is not enough performance data in the grid to analyze and to start getting a grip into this new world that we know so little about. So quality field recorded data sets must be made available for analysis by various parties. I think this is also important that the whole paradigm of data is mine and it's sensitive and so on, data need to be shared for everybody to learn, even manufacturers and system component suppliers to be able to adjust and adapt to the new grid, the new modern grid. Modern tools like machine learning, AI, and fuzzy logic all must be used to learn about the new world. And this new world is, we have no idea what's happening on it right now. We have no idea which are the drivers that drive instability and which are the drivers that improve instability in the grid. So we have to make the road while walking on it. We have to also find new efficient and cost-effective knobs to turn to stabilize the grid. And if I can call a quick example here, if your telephone bill is too high in the company, you've got many ways to get it down. One very effective way of doing it is to publish a list of the highest callers and publish it at the back of the toilet door. And so what I'm trying to say here is there are indirect ways that if we understand the metrics behind it, we can use those indirect ways and methods to improve reliability and efficiency and to protect everybody that sits there. And we also need to identify the drivers that improve stability. And those drivers need to be properly valued and protected. So, you know, uncontrolled growth is not good. We got to identify and value what it is on that side. Let me not preach. Thank you. Minimum demand is quite an important issue right now. And I believe that the zone substation will play a very important role in the future with this whole issue around minimum demand. We know it must be fair, it must be fast, and we also have, I think people don't realize it yet, but an audit trail is needed. You need an audit trail and grid code compliance. Grid compliance must be permanently monitored. So on top of whatever we do to intervene, there will be an audit trail and some data required to manage this kind of thing. Okay. The goal, as I mentioned before, is not to operate the grid at its extremes. It is rather to operate it as close as possible to its design specification. Now, if you do that, it will ensure longevity, and a good return on investment on all connected assets. So right now, I know that many systems throughout the Australian grid is running on high voltage just to accommodate the renewables that feed into the grid. And frankly, it's not the right way. It's not the right way. It's not the right words that I'm looking for. But by doing so, we do have an impact on the reliability of all equipment that hangs around it. So that balance needs to be found. And I believe that the OTELLO system can play quite an important role there in the controlling part as well as the monitoring. So it's not just, don't see us just as a monitoring system on that side. We can have access to the Internet of Things or direct access to tap changer controllers or protection relay or cap band controllers from within the system. Now, our engineers have just scratched the surface. I think the foundation is laid. The platform is out in the field. It's been certified Class A by NMI in the Netherlands. The billing integrity is done. We've got quite a few years under the belt, and we just in the final stages of an ESCOM tender calling for 1,300 devices here in South Africa. And currently we are operating very close to 1,000 devices already on our system on behalf of about 65 to 70 individual customers from all over the world right now on that side. So the important one here is we need to grow, but to grow, we need to have questions being asked. And we need partners to team up with us and use us as a technology partner to grow and to grow the market and to grow the needs that is out on that side. So please talk to us. Questions and answers. Can you unmute the microphones for us? And all right.